And then if you guys have some questions, we can go through it. I'm sure it's a little bit overwhelming. Okay, so as I was saying, yeah, so many of these places here are two-dimensionally mapped, right? So Tokpo here, let me show something more nice. Google satellite map. If you look at Tokpo, I think this is just a locality or something, yeah. It's just some locality in the middle of nowhere. Voila. If you look at the bottom of the screen, this is at 77.512 latitudes. I mean, instead of looking at this, let's look at some passes. Let's look at some passes in Google, why not? Well, if you look at the Barala Chala is so let's say this pass here. If you look at the Tempola is a pass between Lahore. Well, it's a little bit, it's completely full of snow here. If you look at the Tempola, it's located at 77.03039 longitude east and 32.477092 latitude north. And this is a little Chinese maybe for you, but if you want to know more about latitudes, longitudes, check out my navigation bootcamp on my blog. So now, okay, that's fine. It's at this location, latitude, longitude, so I know exactly where on the planet it is. But it would also be useful, obviously, also to know what is exactly the altitude, what is the elevation of this place. So that is also very beautiful, right? Once we start looking at the mountains as a three-dimensional space, it becomes much more powerful because then basically you will know the altitude of the passes, the lakes, the villages. If we have a trail here that goes through Tempola, I think there should be some trail that I mapped, voila. Here, one trail that goes from one of these maps. It would be nice to know what is the steepness. Of course, I can look at it on a topographic map here, like OpenTopo, and I will see the topographic lines. I see here it's quite steep, the contour lines are close together. But it would be useful that I can do some, that I know exactly how the trail goes in a three-dimensional space. For that, actually, we need what we call DEM. We need digital elevation data. DEM. So what is DEM? DEM is a digital elevation model of the planet. Basically, it's like a 3D model. It's a 3D topography, a 3D elevation, 3D terrain, you can say, which has been digitally mapped, so with latitude and longitude at different points across the planet. They are I think in the year 2000, the NASA has launched some satellites which have sampled the entire planet except the North and the South Pole using a satellite technology. They use specific radar technology for this. And they have mapped the entire planet. So they have basically dropped a radar on the planet on the surface, and they have measured the elevation of the planet at every point. Not at every point, because that would be too much data, but they have done this at every second, every arc second. 1 second corresponds to 1 latitude second or longitude second corresponds to 30 meters. So every 30 meters, imagine every 30 meters, horizontal, vertically on the planet, they have generated a digital elevation model. So they have measured the elevation data. So if you go to QGIS and we take a look at Tempola here, it's been a while since I did this, but I can basically download DEM data for this here as RTM. As RTM is the name of the shuttle mission. It's the NASA shuttle SRTM. I forgot what it stands for. It's basically the name of the mission, the satellite mission, which they used to sample the topography of the terrain. So if I download this from this this is a publicly available data. This is available through the Americans, even the ISRO, the Bhuvan mission, right? The Indian Space Research makes this data available through their satellites free of cost. So if I download the DEM data for this rectangular here, my screen, you will see something interesting happening. So this is like, again, gigabytes and gigabytes of data. The raw data itself is not that useful because it's just like billions of points of data of elevation. Boom, voila. So here you can see the elevation data around the tempola. So you can kind of see here dark areas or valleys. These are like low altitude. And these light areas here, like around the tempola, this whole white region corresponds to, if I look at the topo map, so this, hey, voila, see this range here, this topographic, this ridge here, this high range of mountains corresponds on the SRTM data to white. White means high data, high elevation. Black means low elevation. So once I download this data, so this is basically one chunk here. This is 1 degree by 1 degree. 1 degree is 60 minutes. 1 minute is equal to a land mile. So 1 minute corresponds to 1.852 meters. It's a land mile. So 1 degree probably corresponds to 60, probably 100 kilometer by 100 kilometer. We are looking at such an area. So this, of course, is difficult to look at. As a human being, you don't see actually what's going on here. But once we have this elevation data, right, this, for example, will know exactly what is the elevation. So I can take, for example, all these passes here, like Tempola and Mula Rijot, Kunzumla. So I can take all these passes. I think I've actually downloaded them. No, I think I don't have it in this session, but I think I've downloaded them for the entire Himalayas. And once I have this, I can do certain operations. I can do all kinds of interesting processing, like, for example, toolbars, panels. Let me do a little bit of processing. Like, this has some really advanced processing tools here. Let me minimize this bar a little bit. Soupy. So voila, I can do all kinds of mathematical, geographic processing. So for example, I can take all these passes. These are the 1,000 Himalayan passes here. Okay, see, this is the name of, if you look at it, there will be some 1,025 right now, which have been mapped. This is basically mentioned as, in OSM, this is extracted from OSM, tagged as mountain pass equal to yes. It has the latitude and longitude, and it has a name. But what I would like to know, for example, I want to know the elevation. So I could do certain things. I could drape. Of course, you need to be familiar with the terminology, but I could drape all these mountain passes, which have been queried from OSM in this table. And I can use, for example, what is it here? This is the one that I've downloaded, the DEM data, N32. So I can drape it using N32. Voila, there it is. So I can extract the elevation data from this digital elevation model, and it will basically it will basically pick at every pass point here, at every latitude, longitude, is gonna extract the elevation data from my digital elevation model. So if I run this, voila, I get basically a new table here. Voila, if I look at this table, and I go to the tempola, it would have taken a tempola and whatever passes were in this place. There's a lot of passes in the Himalayas. I think we have enough to explore for a lifetime. So if I look at oh man, so many. Tempo, where are you, tempola? Here, tempola, if I look at this row here, and I go to the end, it would have added a column called it should have added actually a column called I think it has added a column called ILI, elevation. So it has basically checked the latitude, longitude of the tempola. It has looked it up in this digital elevation model, and it has extracted 4,930 meter altitude is the pass of the Temple La. So you can see, right, once you have three-dimensional data on top of this two-dimensionally geocoded passes and routes, you can do amazing stuff. I can do other stuff like, say, for example, I have these plugins like, say, the profile tool. Profile tool, I can generate a profile of an of an hiking trail. Say, for example, let me show a little bit less here. Let me just take the routes in OSM, the hiking routes. Voila. Let me go, for example, to the. Let me go to this one. Let me go to the Hamta Pass. I guess some of you guys know the Hamta Pass. Yeah, here is the Hamta Pass. I think we're still looking at some stuff here. Here is the Hamta Pass. Okay, so what I could do now is I could generate, basically I could use this tool, this is a plugin, to generate basically take the elevation at every point along this trail. So I can, for example, select the Hamta Pass. So I'll have to now click on route hiking. I will have to select something here, add layer, I guess, yeah. Not profile, oh, okay, sorry, I have to select my elevation data here. Whoops, that's it. And then I'll have to select the routes, the OSM hiking routes here, voila. And then it should be possible, where is it? Selected layer, voila, okay. I can select this pass here. Yeah, there it goes. And it's gonna calculate like an elevation profile of this Hamta Pass. So completely mathematical, it will look at the digital elevation data that I downloaded from the NASA, from the satellite. Look at, say, the location of every point along this hiking route, and it will basically generate an elevation profile, just like the same I was doing in waypoints, in the waymarked trails. It will do a similar thing. So here we have the same Hamta Pass here, HP. If I look at the Hamta Pass here, I could do the same, generate this kind of elevation profile by looking at digital elevation model. So see, pretty powerful stuff actually. In this place, I think we are not calculating anymore. I think QGIS, I'm running the latest experimental version of QGIS. I think it has crashed. So, but normally you can generate the same type of elevation profile. So you can see like GIS is very powerful once you have the geo data, once you have the three-dimensional elevation terrain data, you can generate all kinds of useful computations. You can, for example, I showed you some other things I did. You can calculate, for example, along a trail, which are all the important points along the trail. So this will take a little bit of processing, so I'll just show you the result. A while back, I took all these 300 trails hiking routes from OSM, and I've calculated all the villages, all the campsites, the passes, all the important points along each route, basically by calculating the distance of these points from the route. So for example, if you look at this table here, this I've exported from, but if we take, for example, a single route, Kaliheni. So if you look at Kaliheni Pass, I started calculating in QGIS from the starting village at Pangan. Along the Kaliheni hiking route is there anything nearby? If anything is there within, say, 300 meters, I've just automatically calculated this in QGIS. Hey, what is this? What type of OSM point is it? This is a temple, this is a campsite, this is a village at 9 kilometers. This is a camp site called Sanghar at 22 kilometers at this altitude. So I've extracted elevation data. There is an Alpine lake at 29 kilometers from the start. There is a Kaliheni lake here at 43 kilometers. There is the Kalihini Pass at the highest point at 4,700 meters, 39 meters from my marked route. So you can see QGIS is extremely powerful. Once you map all the villages, the campsite, the places, the glaciers, the routes, the lines, the lakes, the glaciers, the forest, you can do any kind of calculations. You can calculate how much percentage your trail goes across the glacier, how many lakes, how many campsites you cross, what is the elevation at any point along the trail. So once you kind of map everything properly, from these paper maps, from these databases like IMF, NGA, from imported GPX files, you basically have everything can actually be mathematically processed, basically. So that is the power of QGIS, basically. And one more interesting thing is that once you kind of map this, you can generate all kinds of maps, right? So you can, for example, this is too much data. So you can just basically generate one map that shows just the passes. So this is, say, now a beautiful view. Say I want to publish this to the user. There are certain plugins here, like I think it's somewhere here. Yeah, it's a tool called QGIS to Web. I can create a web map out of this. A web map basically means I can export this to HTML and JavaScript, this particular view. I could also decide whether I add the hamlets to this. I can add the districts to this. I can add the glaciers to this, yes or no. And after export this as an HTML view, I can then upload it and share it with anyone in the world. So for example, if you look at my blog, I've taken one map. This was already something from 2 months ago. Now we're done. So here I've mapped one specific QGIS view that shows the passes, the lakes, and the trails on top of a beautiful OSM view. And I've basically rendered it on my website. So these are basically a set of HTML files. And it also shows the glaciers here. It shows the routes in different, it shows the exact routes from OSM. And then it also shows some approximate trails, which are shown in dotted line, which are kind of not GPS files. So we don't know the exact trail. It's not a recorded trail, but it's like an approximate trail, which I've taken, I think, in this case, from Depi maps. So here already you'll find a beautiful map, right, which hides all the villages and a lot of noise. It just clearly shows you at any zoom level. This QGIS view nicely hides data. Only as you zoom in, it will bring out more and more passes, not to make it too noisy, the view. And it just shows you the main features like the peaks, the lakes, and the passes, which would not be visible on standard OSM until you really zoom in quite a bit. See, you can only see the peaks popping in on the OSM base layer or the trails here after you really zoom in a lot. So having these things at the top level give you like an extremely good overview. These are digital maps, so in addition, in contrast to paper maps, you can look at them at any zoom level. I can look at, say, like 1,000 kilometers level. I can look at that at just 100 kilometers. I can look at them at just here 10 kilometers. I can change the map to a contour map so you can see the terrain. So QGIS, I mean, with QGIS, you basically can generate any view and export this view to the web so that anyone can see the kind of maps that you publish. So planning actually to publish nice maps district-wise for the Himalayas, so it will become easier. Instead of looking at people getting scared of 1,000 passes, they can just look at the Chamba Valley or at the Kulu Valley or at the Kinor or at other specific districts to make it less overwhelming and less crowded on the map. Voila, that's it, guys. Any specific questions? Sorry for bombarding you with a lot of information.